Hello, my name is Katie, and I'll be presenting the medication Palbociclib today. Palbociclib targets advanced metastatic breast cancer by selectively inhibiting cyclin-dependent kinase 4 and 6, or CDK4/6. Approved by the FDA in 2015, this synthetic drug halts cancer cell proliferation by arresting the cell cycle. It's most effective in combination therapies where it prevents tumor growth and progression. Palbociclib's efficacy is rooted in its unique chemical structure, which includes three key components. The pyridyl 2,3-D pyrimidine 7,1 core, central scaffold of the drug. This fused heterocyclic ring system is crucial for its inhibitory activity and allows for specific binding to CDK4/6. The piperazine ring enhances the molecular flexibility of palbociclib, plays a significant role in optimizing the drug's interaction with surrounding residues in CDK4 and 6. Lastly, we have the aminopyridine. It is vital for palbociclib's selective binding to CDK4, ensuring targeted inhibition. This selectivity contributes to the drug's efficacy and minimize off-target effects. I've outlined those three structures here. And we can see the pyridyl pyrimidine 7,1 core over here with the aminopyridine nucleus over here. And also in the end, really on the tail, it is the piperazine ring. CDK4/6 palbociclib's primary targets regulates the transition from the G1 phase to the S phase in the cell cycle. Normally, CDK4 and 6 complexes phosphorylates the retinoblastoma protein, releasing E2F transcription factor that drives DNA replication. Palbociclib disrupts this pathway, halting cancer cell proliferation and slowing tumor growth. And I have a picture of the target, what it looks like, the CDK. Palbociclib achieved its inhibitory effects through specific molecular interactions. First, we have the aminopyridine, the NH. It forms hydrogen bound with valine 101 in CDK4/6 binding pocket. This interaction plays a role in anchoring palbociclib within the active site, contributing to its binding affinity. As we can see over here, the green bluish dotted line, the valine 101 with the aminopyridine interaction over here. Second of all, we have the pyridyl 2,3-D pyrimidine 7,1 core. It engages in hydrogen bonding with histidine 100 in the pocket. This hydrogen bond stabilizes the inhibitor within the binding pocket and helps maintain the proper conformation of the inhibitor, as we can see by this a bit larger blue dot line with the interaction with the histidine 100. Palbociclib undergoes extensive metabolism in the liver, primarily through oxidation and sulfonation. The cytochrome P450 is isoenzyme 2A and sulfotransferase 2A1 are the main enzymes involved, transforming the drug for excretion. As we can see, the potential oxidation site, I have a few examples of the potential oxidation sites here. So in the palbociclib M3, we can see there was oxidation on the tail of the piperazine ring. In the M11, we can see it is on the aminopyridine. And in M1, we can see it is really on the pent ring. So personally, I think the reason why those sites are potential for oxidation was because the nitrogen atoms in these rings modify electron density on adjacent carbons, making them more accessible for oxidation by enzymes like CYP3A. So after oxidation, a hydroxylated metabolite can then be a target for sulfonation. Sulfonation typically occurs on the newly introduced hydroxyl group, converting it into a sulfate ester. This sulfonation, often mediated by the SULT enzyme, increased compound's water solubility, facilitating its excretion. And you can see here the palbociclib M8. We have a sulfonation at the piperazine ring, where the potentially have been oxidation site before, and now it have been converted into a sulfate ester. So one research I found was on the potential structure activity relationship was on the piperazine ring. So they modified the piperazine ring with various carbamates and amines and found that this structure, compound 4E, exhibited superior inhibitory activity compared to standard palbociclib and demonstrated potent tumor growth inhibition in vivo. They have not demonstrated why this could be this could result in the superior inhibitory activity, but it is potential something to worth to be it is something worth to look at in the future. So some other drug properties I want to mention is palbociclib is mainly eliminated through feces, and with its half-life about 29 hours. Palbociclib presents a linear pharmacokinetic profile, and its peak plasma concentration was observed 6 to 12 hours after oral administration. Because palbociclib is metabolized by CYP3A, drugs that either inhibit or induce this enzyme can affect palbociclib's effectiveness and side effects. And here is the reference slide. Thank you.